A stone block heavier than 20 elephants stands where ancient hands placed it. The secrets of the megalith builders involve tools and methods history has completely forgotten, pointing to a past far more clever than we assume. By the end of this, you will see these ancient sites not as primitive ruins, but as masterpieces of engineering that force us to rethink our entire timeline. How did they cut granite with such impossible precision, and what forgotten science allowed them to move mountains of stone? What does our fascination with these silent giants say about our own lost potential? That single stone block is just one piece of a planet-wide puzzle. From the windswept plains of Salisbury to the high Andes of Peru, humanity displayed a shared, almost obsessive drive to build on a colossal scale. Isolated cultures, separated by vast oceans and millennia, all arrived at the same staggering conclusion: to express their deepest beliefs in the most permanent material they could find, stone. Look at the brooding moai of Easter Island, their immense stone faces gazing inland from a remote Pacific shore. Then consider the mysterious, geometric forms of the Yonaguni Monument, submerged off the coast of Japan. Are these structures natural or shaped by human hands? A debate that itself highlights the sheer scale of what we are trying to understand. This was not a single, spreading idea, but a global tapestry of engineering, woven with different styles, materials, and purposes. Some stones were rough-hewn and powerful, like the dolmens scattered across Europe. Others were cut with such impossible precision they seem like a form of Stone Age origami, fitting together without a sliver of light passing between them. What universal human impulse led to such monumental endeavors? Was it a need to honor the divine, to mark territory, to create a legacy that would outlast the spoken word, or perhaps something else entirely, a forgotten understanding of the world and our place within it? Recognizing this global phenomenon is crucial, for it shows that the knowledge of moving and shaping mountains of stone was far more common and far more sophisticated than our standard histories ever suggest. This is the true scale of the mystery we are about to unravel, a mystery built not in one place but across the entire ancient world. So what exactly defines a megalith beyond its immense weight? The word itself comes from ancient Greek, meaning simply large stone, but that definition barely scratches the surface. A true megalith is not merely a boulder. It is a carefully chosen and deliberately placed component of a much larger design, a single piece in a grand architectural puzzle. These structures were built with purpose, often serving as sophisticated calendars, sacred spaces, or powerful social symbols. Think of Newgrange in Ireland, an enormous earthen mound older than the pyramids. For just a few precious minutes at dawn on the winter solstice, a single, narrow beam of sunlight pierces through a perfectly aligned opening above the entrance. This sliver of light travels down a long, dark passageway to illuminate the central burial chamber deep within the tomb. This was not a random occurrence. It was a feat of engineering and astronomy so precise it would have required generations of observation and planning. The true, enduring mystery of the megalith, therefore, lies not only in its staggering scale, but in the profound logistical challenges its creation presented. How do you quarry a block of stone weighing hundreds of tons without cracking it? How do you transport that block for miles across rugged terrain, over rivers and through forests? And finally, how do you lift it and position it with the accuracy of a master watchmaker? Each of these steps represents a puzzle that modern engineers would find daunting even with our advanced machinery and computer modeling. By understanding these core characteristics, the deliberate placement and the multi-stage construction process, we begin to separate true megalithic sites from other ancient ruins. We start to see the outline of a forgotten genius, a systematic knowledge that allowed our ancestors to manipulate their world on a scale that still defies easy explanation. Legends from across the globe speak of a forgotten tool, one that required no ropes or ramps, but the human voice itself. Stories persist of massive stones becoming light as air, guided into place by the resonant power of specific chants and sacred frequencies. Picture a circle of skilled individuals surrounding a granite block many times their own weight. They are not straining against it with physical force. Instead, they are chanting in perfect unison, their voices blending into a single, powerful tone that seems to vibrate the very air around the stone. According to these age-old accounts, the immense block would then lose its weight, becoming buoyant and easily maneuverable into its precise position. This concept, which sounds like pure myth to our modern ears, finds a curious echo in today's scientific laboratories. Researchers are now developing acoustic tractor beams, using precisely focused sound waves to levitate and move small objects. It is a fledgling science, but it hints at a fundamental principle that vibration can indeed influence matter in profound ways. While mainstream archaeology dismisses these ancient tales as symbolic or metaphorical, the consistency of the stories is striking. Indigenous traditions in the high Andes, for instance, have long spoken of their ancestors using sound to lift and place the colossal stones at sites like Ollantaytambo. Similar narratives exist in parts of Asia, describing a lost knowledge of vibrational science. Perhaps we should listen to these legends not as literal histories, but as vital clues. They may point to a sophisticated, forgotten understanding of resonance, the natural tendency of all objects to vibrate at specific frequencies. If the builders could discover the resonant frequency of a stone, could they have found a way to use that knowledge to neutralize its effective weight, if only for a short time? This idea of using an invisible force like sound to move mountains of rock naturally leads us to wonder what other subtle energies of the natural world the ancients might have learned to harness. The idea of moving stone with sound seems to challenge our very understanding of physics, but a second forgotten tool proposes something even more radical. What if the stones themselves were never moved at all? A revolutionary theory from the world of materials science suggests that many of these impossibly perfect blocks were not quarried but cast like a liquid directly into their final forms. This was not the concrete we know today, but a sophisticated geopolymer, an artificial stone created by chemically reacting local limestone with other natural ingredients to form a slurry that could be poured into mold. When this material hardened, it became a rock virtually indistinguishable from one carved from a mountain, yet it possessed unique properties that natural stone does not. The evidence for this is both microscopic and monumental. Under high-powered microscopes, samples from certain ancient sites reveal chemical components and air bubbles that are not found in natural limestone formations. Even more telling is the curious lack of evidence on the ground. The construction of the Great Pyramid, for instance, would have required the quarrying of millions of massive blocks. Such an operation should have left behind mountains of quarry waste, fractured stones, and discarded debris. Yet the amount of such waste found near the site is surprisingly small, almost as if the primary building material was not extracted, but mixed and poured on location. This single idea completely reframes the entire narrative of megalithic construction. It shifts the story away from a brute force struggle of countless workers dragging incomprehensible weights and toward a quiet, deliberate process of advanced chemistry and engineering. The builders were not just master stonemasons, they were early alchemists, possessing a secret recipe for making stone itself. This knowledge would have dramatically simplified the entire building process, eliminating the need to cut, transport, and lift multi-ton blocks with perfect precision. Instead, workers could have carried bags of powdered rock and buckets of a special slurry, mixing and pouring the stones one by one, achieving those famously seamless, light-proof joints because the stones were not fitted together, they were grown together. If this theory holds, then the true genius of the builders was not in their muscle, but in their mind, a chemical mastery that has remained hidden in plain sight for thousands of years. A copper chisel would shatter against the unyielding surface of granite. The sheer hardness of the stone itself presents a paradox that has long puzzled archaeologists. How then do we explain the evidence left behind, not in scrolls or paintings, but in the stone itself? Deep within the Egyptian quarries, workers left behind unfinished obelisks and, more tellingly, core samples. These are cylindrical plugs of granite drilled out from the bedrock. The surface of these cores is not rough or chipped. They are marked by perfectly symmetrical, deep spiral grooves, as clean and regular as the threads on a modern screw. This pattern reveals a drill that did not simply pound and crush the rock. It cut through it, sinking downward with a steady, relentless feed rate that a simple copper tube with sand abrasive could never achieve. The force required and the precision of the cut point toward something far more advanced. The most plausible explanation is a drill bit tipped with a substance harder than granite itself. Imagine a tool embedded with diamonds or perhaps crushed corundum, a naturally occurring mineral second only to diamond in hardness. This crystalline dust would have been sintered or fused onto the cutting edge of a copper drill, creating a composite tool of astonishing cutting power. This was not just a harder hammer, it was an early form of precision machining. This lost technology finds its ultimate expression not in quarries, but in finished artifacts of breathtaking accuracy. Look at the stone boxes, often called sarcophagi, found within the Great Pyramid's so-called relieving chambers. These are massive containers carved from single blocks of granite, their interiors hollowed out with such exactitude that the corners are perfectly square and the surfaces flawlessly flat. The fit between the lid and the box is so precise that, even today, you cannot slide a piece of paper between them. This is a tolerance of mere millimeters, achieved on an immense scale. It speaks of a process far removed from brute force. It suggests master craftsmen working with calibrated tools, with an understanding of geometry and measurement that was every bit as advanced as their materials science. The knowledge of how to create and use these diamond-tipped tools must have been incredibly rare, a closely guarded secret of a specialized guild. When that guild faded from history, the technique vanished with them, leaving behind only the impossible proof carved in stone for us to rediscover. Run your finger along the join between two stones in an Incan wall, and you will feel nothing but a smooth, unbroken plane. These are not simple blocks stacked one upon the other. They are intricate, three-dimensional puzzles, with each stone uniquely shaped to embrace its neighbors with a complexity that beggars belief. This is not mere stonemasonry. It is a form of lithic art, achieving joins so impossibly tight that not even a razor blade, the thinnest of modern manufactured objects, can find a gap to penetrate. The standard explanation of patient workers grinding stones together for years with sand and water feels insufficient. Such a method might create a flat surface, but it could never account for the intricate, interlocking curves and the perfect internal corners found in the most advanced walls. The creation of these forms implies something else entirely, a master system of measurement and replication. Each stone had to be precisely measured in its rough state, its final, complex shape calculated, and then that shape carved with flawless accuracy, all before it ever met its neighboring block. This points toward the use of sophisticated templates, perhaps made from wood or metal, that could transfer a perfect design from a master plan onto each individual stone. But a template is only as good as the tools used to execute it. The builders must have possessed calibrated instruments, devices for ensuring true right angles and perfectly straight edges, tools that functioned on principles of geometry we would still recognize today. The fact that this was accomplished across different cultures, from the granite temples of Egypt to the andesite fortresses of the Andes, suggests a shared, profound understanding of form and fit. This was a global standard of quality control that has rarely, if ever, been matched since. The absence of mortar in these perfect unions is the ultimate clue. It tells us the builders were not relying on a filler to hide their mistakes. They were so confident in their precision that they designed their structures to rely solely on the perfect friction of stone against stone, a testament to a knowledge of metrology, the science of measurement that history has largely forgotten. This level of accuracy forces us to ask what kind of mathematics was necessary to make it all possible. These perfect stone joints required a master system of measurement. The dimensions of the world's great megalithic sites reveal a profound and unsettling truth, that their builders possessed a unified mathematical language. A researcher named Alexander Thom, after surveying hundreds of stone circles across Britain, proposed the existence of a standard unit he called the megalithic yard. It was not a rough estimate. It was a precise measure, approximately 2.72 feet, which he found repeated with astonishing consistency from Scotland to Brittany. This was not a simple ruler for laying out a foundation. It was the foundation of a forgotten science, a system of geometry so advanced it encoded the very laws of the cosmos into stone. Visualize the sprawling layout of Stonehenge. Its concentric rings of stones and holes are not placed at random intervals. Their diameters and the spaces between them are based on a complex, interlocking web of Pythagorean triangles, right-angled triangles whose side lengths form perfect whole number ratios. This is a mathematical concept that mainstream history claims would not be formally discovered for another 2,000 years. Yet here it is, set in stone for anyone who knows how to look. The Great Pyramid presents an even more staggering example. The ratio of its perimeter to its height equals 2 times pi, a fundamental constant relating a circle's circumference to its diameter. This is not a rough approximation. It is precise to a degree that defies coincidence, suggesting the builders had a sophisticated understanding of this irrational number long before it was formalized in ancient Greece. This was far more than practical geometry for ensuring a wall stood straight. For these ancient master builders, mathematics was a sacred language and construction was a spiritual act. They were not merely stacking rocks, they were aligning human creation with the perceived divine order of the universe. By building structures whose proportions reflected the golden ratio, pi, and the precise movements of the sun and stars, they were creating a permanent resonance between the earth and the heavens. Their temples were models of the cosmos, solid-state computers built to harmonize with the fundamental frequencies of existence. The builders were therefore more than engineers. They were philosopher-mathematicians, weaving their deepest understanding of reality into the very fabric of their monuments. These sites were their libraries, designed to withstand the erosion of time and the loss of written records. They encoded a complete worldview, a synthesis of number, form, and celestial motion, into a format that could last for millennia. The tragic fragmentation of this knowledge, its descent into legend and then into silence, represents one of history's greatest intellectual losses. We are left with the magnificent, silent question of the stones themselves. a permanent record of a science that saw the universe as a single, interconnected equation. The mathematical perfection of these structures found its ultimate expression not on the ground but in the sky. These silent stone circles and towering monuments were, in fact, colossal astronomical machines. Their alignments tracked the solstices, equinoxes, and the complex cycles of the moon with a precision that can rival modern instruments. At the Mnajdra Temple complex on Malta, for just a few fleeting moments during the equinox, a sliver of sunlight pierces through a perfectly aligned opening, casting a brilliant beam of light onto a specific stone slab deep within the sanctuary. This was not an accident of architecture. It was a deliberate, breathtaking feat of engineering designed to mark the moment of celestial balance, when day and night are of equal length. Achieving such a precise alignment required more than just advanced mathematics. It demanded generations of patient, meticulous observation of the heavens, a sacred science passed down from parent to child for centuries. This astronomical purpose reveals a profound and pressing need within these cultures. The ability to predict the changing seasons with absolute certainty was a matter of survival. It told them when to plant their crops, when to harvest, and when to prepare for the long, lean months of winter. For a society dependent on agriculture, this knowledge was power, the difference between prosperity and hardship. But this need ran even deeper than the practical. The immense effort required to align multi-ton stones with the movements of the sun and stars speaks to a cosmology where the earthly and the celestial were intimately, inextricably linked. The sky was not a distant, separate realm. It was a living part of their world, a divine clockwork that governed the rhythms of life, death, and rebirth. By building these observatories, they were forging a permanent connection between their community and the cosmos, anchoring their sacred rituals to the timeless dance of the heavens. They encoded this vital, celestial knowledge not in fragile scrolls, but in the most permanent medium they had, the very landscape itself. This was a legacy of stone and light, a promise that the wisdom of the stars would never be forgotten. The seamless joints and celestial alignments of these monuments all rest upon a single, brute force challenge, extracting the stone itself. A block of granite weighing over 1,000 tons is not simply lifted from the earth. The quarry where it was born presents the first and perhaps most daunting puzzle. At the ancient site of Baalbek in Lebanon, a single limestone block, known as the Stone of the Pregnant Woman, remains in its quarry, a colossal testament to ambition. This monolith is larger than a modern commercial whale. Its very existence forces a simple, staggering question. How did they even begin to cut such a thing free from the living bedrock? And what did they know that allowed them to believe moving it was even possible? The methods for this initial step were as varied as the stones themselves, each technique a careful negotiation with the material. For softer stones like limestone, workers might have used a process of thermal shock. They would light controlled fires along a desired fracture line, heating the stone until it was nearly glowing. Then, just as carefully, they would douse the hot rock with water or vinegar. The sudden, intense cooling would cause the granite or limestone to expand and contract unevenly, creating a clean, predictable crack. It was a method of using the stone's own internal stresses against it, a form of elemental jujitsu. For harder, igneous rocks like granite and basalt, this thermal technique was less reliable. There, the evidence points to a more patient, almost meditative process. Workers would carve a narrow channel along the intended cut line. Then, using round stone hammers made of a material harder than the rock itself, like dolerite, they would pulverize the granite along this groove, literally pounding it into sand, one meticulous hammer strike at a time. This was not a quick process. Liberating a single massive block could have taken a team of workers many months or even years of relentless, focused labor. The true genius, however, lies not in the sheer effort but in the consistent success. These builders repeatedly extracted near-perfect, unfractured blocks, some the size of small houses. This was not a matter of luck. It was the result of a systematic, deeply refined quarrying technology, a profound understanding of geology and fracture mechanics that has left almost no trace behind, except for the perfect blocks it produced. Freeing the stone from the earth was a monumental achievement, but it was only the prelude to an even greater feat of engineering, one that defies our understanding of friction and force. That colossal stone, now free from the quarry, faced a journey of miles. Moving a 100-ton block across rugged terrain is a logistical nightmare that has spawned theories from the practical to the seemingly impossible. The classic image is one of immense human effort, with legions of workers straining against ropes, dragging a massive sledge over a path of lubricated log rollers. This method has been demonstrated on a small scale, showing that wetting the sand or clay in front of a sledge can dramatically reduce friction. Yet, this practical solution begins to fray when we consider the true scale of the challenge. How would such a system work on a soft, muddy plain, where the immense weight would sink the rollers and the sledge into the earth, leaving behind deep, permanent ruts that we simply do not find at many sites? How would they navigate a steep, rocky hillside, or cross a river without a bridge capable of supporting such an unimaginable load? The sheer physics of moving the largest stones, like the 1,000-ton monolith at Baalbek, pushes the log roller theory to its breaking point, demanding a workforce of such staggering size that it feels more like myth than a feasible historical account. The inadequacy of these conventional explanations has, understandably, given rise to more speculative ideas. What if the builders discovered a way to make the stone itself lighter? Stories and fringe theories speak of levitation, of using specific sound frequencies to create a vibrational field that neutralized gravity, or of harnessing mysterious earth energies, perhaps a vortex of force, to guide the blocks effortlessly into place. While mainstream science dismisses these concepts, their persistence is a direct response to the gaps in our own understanding. They represent a deep, intuitive sense that we are missing a fundamental piece of the puzzle, a lost principle of physics that turned an impossible task into a manageable one. This is the core of the mystery, a journey that was clearly undertaken, but whose method remains just out of sight. Perhaps the truth lies not in a single, forgotten technology, but in a combination of ingenious, simple methods we have overlooked. Maybe the builders used a complex system of pivoting and rocking, slowly walking the stones across the landscape in a delicate, controlled dance. Or perhaps they employed a form of advanced leverage or counterweight that has left no archaeological trace. The path from quarry to sacred site is a ghost story, a narrative of immense effort written in a language of engineering we can no longer fully read. It forces us to question not just their methods but the very nature of the problem itself. What if we are asking the wrong questions entirely? Moving a mountain of stone required a mountain of people. The logistics behind these workforces are as complex as the engineering itself. For generations, the dominant image was one of slavery, of countless individuals driven by the lash to fulfill the whims of a tyrant. This narrative, however, is being dismantled piece by piece, not by reinterpreting the stones, but by examining the places where the builders actually lived. The workers' villages unearthed near the Giza Plateau tell a profoundly different story. These were not squalid prison camps, but organized settlements with evidence of robust medical care, diets rich in meat and fish, and even facilities for large-scale bread and beer production. These people were not starving laborers. They were well-fed, skilled participants in a project of immense national importance, the discovery of worker graffiti, identifying teams with names like the Friends of Khufu or the Drunkards of Menkora, hints at a sense of camaraderie and even pride in their work. This evidence paints a portrait of a rotating, seasonal workforce, perhaps farmers who came to contribute their labor during the Nile's flood season when their fields were underwater. The construction of the pyramids was likely not an act of oppression, but a collective act of faith, a civic and religious duty that bound the society together. This shifts the entire perspective on these projects. If the workforce was willing, even devoted, then the secret to their success lies not in the crack of a whip, but in the power of a shared belief. The motivation to build was woven into the very fabric of their spiritual and social identity. To contribute to such a monument was to secure one's place in the cosmic order, to participate in a ritual that ensured the continued harmony of the kingdom and the favor of the gods. This level of voluntary, coordinated effort requires a sophisticated system of administration, from foremen and architects to scribes and supply officers, a hidden bureaucracy as impressive as the monuments it managed. The true forgotten tool, then, may have been a form of social contract, a cultural engine capable of harnessing the collective will of thousands toward a single, glorious goal for generations. The stones themselves may hold the final, silent testimony to their own true age. Look closely at the weathered flanks of the Great Sphinx of Giza. The deep, undulating, vertical channels carved into its limestone body do not look like the work of a dry, sandy desert wind. That kind of erosion creates sharp, horizontal facets. Instead, these patterns are strikingly familiar to geologists. They are the classic signature of heavy, prolonged rainfall, water running in sheets over the surface for centuries. This observation forms the core of the water erosion hypothesis, a radical idea that challenges the foundation of ancient history. If the primary force that weathered the Sphinx was water, then the structure must have been built during a time when the Egyptian climate was significantly wetter. The last such period ended over 7,000 years ago, pushing the Sphinx's origins thousands of years further back than the orthodox timeline allows. This single geological clue unravels the entire conventional narrative. It suggests that the Sphinx, and perhaps the entire Giza plateau, is not solely the product of the Old Kingdom Egyptians, but the legacy of a far more ancient, sophisticated culture. A culture that flourished in a green Sahara, a lost world that existed before the deserts we know ever formed. What became of this precursor civilization? The answer might be written in the most persistent human stories ever told. Cultures across the globe, from the Mesopotamians with the Epic of Gilgamesh to the Greeks with the story of Deucalion, share a foundational myth of a great world-engulfing flood. These are not just tales of a heavy rain. They describe a cataclysmic deluge that wiped the slate of history almost clean. Could these universal memories be the echo of a real climatic catastrophe that marked the end of that wet epoch? A rapid shift in global climate at the end of the last ice age, around 12,000 years ago, caused sea levels to rise dramatically and weather patterns to change violently. Such an event could have submerged coastal cities and devastated the heartlands of an early agricultural society, leaving only their most durable creations, their megalithic structures, behind on the high ground. The survivors of this collapse, scattered and struggling, would have carried with them fragments of the old knowledge, the skills of stoneworking and astronomy, which they later passed down to the cultures we recognize today, the Egyptians, the Sumerians, the Incas. This theory does not diminish these later cultures, but reframes them as inheritors. It suggests that the true megalith builders were a shadowy, pre-pharaonic people whose name and specific history are lost to us. Their legacy is not in written records, but in the profound and puzzling monuments that have stood for millennia, silent witnesses to a forgotten chapter in the human story. The stones were not the beginning of something, but the enduring remnant of a world that came before. A polygonal wall in Cusco shudders during a major earthquake, the stones shifting and then settling back into perfect alignment as if nothing happened. This is the genius of Incan polygonal masonry, where every irregular, interlocking block acts as a shock absorber, distributing energy throughout the entire structure. The builders understood their environment was alive with geological movement, and their architecture was a direct, brilliant response to that reality. Half a world away, the Lion Gate of Mycenae presents a different philosophy. Here, the Cyclopean walls are built from enormous, roughly fitted limestone boulders, their sheer mass and weight intended to project an image of raw, unassailable power. The goal was not flexibility, but permanence and intimidation, a fortress meant to awe any potential challenger. Then there is Stonehenge with its elegant trilithons, two massive vertical stones supporting a horizontal lintel. This was not about defense or seismic stability, but about creating a precise, stable frame for celestial observation, a permanent window onto the cosmos. Each style is a clear cultural signature, a direct reflection of local priorities. The Egyptians, masters of the monumental plane, sought smooth, flawless surfaces that reflected the sun's power and created an aura of divine perfection. They built for eternity, but a very specific kind of eternity, one of geometric purity. The Incas, in contrast, built for an active earth, their walls dancing with the land itself. This global comparison reveals a profound truth. While the cultural expression was unique, the fundamental, underlying challenge was the same. How do you consistently and reliably move and position stone blocks that weigh more than a family car? The polygonal blocks of Peru required just as much precision, if not more, than the rectangular blocks of Egypt. The trilithons of England demanded a sophisticated understanding of leverage and balance to hoist those lintels into place. The common thread is not a single technique, but a shared, seemingly impossible capability. Did cultures separated by oceans and millennia simply arrive at the same brilliant conclusions independently, solving the physics of megaliths through parallel genius? Or does this widespread proficiency point to a much older, common source, a foundational school of stonecraft that was carried, adapted, and refined by cultures across the globe, leaving behind a puzzle written in a dozen different dialects of the same forgotten language? This idea of megaliths as energy devices begins with the very stone they chose. Many of these ancient sites are built from granite, a rock naturally rich in quartz crystal. If you squeeze a quartz crystal, it generates a tiny electrical charge, a phenomenon known as the piezoelectric effect. Now, envision a massive stone circle erected directly over a subterranean water flow. The constant, subtle pressure of the moving water deep below, combined with the natural seismic hum of the Earth itself, could theoretically have placed the entire structure under a state of continuous mechanical stress. Proponents of this theory suggest that the carefully positioned stones acted as a network, channeling and perhaps even amplifying this subtle energy into a usable field. This could explain why so many of these locations feel so profoundly different to visitors, a sensation often attributed to something far more mysterious than architecture. The theory extends to the famed elongated skulls found in various ancient cultures. Some researchers have speculated that these cranial modifications were not merely aesthetic, but a deliberate biological adaptation, an attempt to increase the brain's capacity to act as an antenna for these very energies, a living component in a vast stone-based technological system. While mainstream science dismisses this as pure speculation, the underlying question remains compelling. Why did cultures go to such incredible effort to build in specific, often inconvenient and geologically active locations, if not for a reason we have yet to fully comprehend? It reframes these monuments from passive temples into potentially active devices, suggesting a form of lost science that viewed the Earth not as an inert platform, but as a living, breathing source of power. This was not a science of gears and levers, but one of resonance and vibration, a harmonious dialogue between human creation and the hidden forces of the planet. Deep within the crypts of the Hathor Temple at Dendera, a stone relief presents a puzzle that refuses to be solved. Etched into the wall is a bizarre and unmistakable image, a large, elongated object that looks remarkably like a modern light bulb. Inside its bulbous end, a snake stretches along its length, connected by a cable to a box held by a standing figure. To some, this is not a mythic symbol, but a literal diagram of advanced technology, a clear depiction of electric light in ancient Egypt. The mainstream interpretation is far more symbolic, explaining the scene as a complex representation of a cosmic creation myth, with the snake symbolizing the emergence of life from a lotus flower. Yet the precision of the carving continues to fuel debate. If the alternative view holds any truth, it would fundamentally rewrite our understanding of how the megalith builders worked. How did they achieve such flawless cuts in the pitch-black depths of pyramid chambers, or in the windowless halls of subterranean temples? The use of flickering torches or oil lamps would have left behind telltale soot stains on the ceilings, yet many of these spaces remain conspicuously clean. Could the answer be that they were illuminated by a clear, steady, and smokeless light, a technology that was later lost for ages? The Dendera relief stands as a powerful reminder that our interpretations of the past are often limited by our own assumptions. It challenges us to look at these ancient symbols not with a dismissive eye, but with a sense of open-minded curiosity, asking what other secrets might be hidden in plain sight, waiting for us to see them in a new light. A single man working in secret under the cover of the Florida night achieved what modern machinery would find difficult. Edward Leedskalnin, a slight figure standing just 5 feet tall and weighing barely 100 pounds, single-handedly quarried, carved, and positioned over 1,000 tons of solid coral rock to create the enigmatic wonder known as Coral Castle. His methods were as mysterious as those of the ancient builders we have been exploring. He allowed no one to watch him work, and when curious neighbors pressed him for an answer, he would offer only a cryptic reply. He claimed to have understood the laws of weight and leverage, insisting that the pyramid builders possessed the very same knowledge. The tools he left behind were simple, almost comically inadequate, a collection of old car jacks, chain hoists, and rusted metal tripods. None of them explain how he lifted and precisely set stone blocks heavier than automobiles, including a perfectly balanced 9-ton revolving gate that moved with the gentle push of a single finger. This was not a feat of brute strength. It was a demonstration of a profound and forgotten principle. Leedskalnin's own writings hint at his focus on magnetism and the subtle currents of energy that flow through the earth and all matter. He spoke of understanding the cosmic forces that hold the planets in their orbits, suggesting he had learned to manipulate those same forces on a small scale to counteract the weight of stone. Did he rediscover a form of magnetic levitation, a way to make the dense coral rock temporarily weightless? Or did he master a sophisticated application of counterweights and pivots, a simple yet brilliant system of physics that has eluded modern engineers? Coral Castle is not an ancient ruin, but a modern monument to the enduring mystery. It proves that the secrets of the megalith builders were not necessarily lost in a global cataclysm, but could have been quietly preserved, or independently rediscovered by a solitary individual with the patience and insight to listen to the whispers of the past. This one man's life work stands as a permanent challenge, a silent dare to our modern assumptions about what is possible. If he could do it alone with early 20th century materials, then the entire narrative of how the pyramids or Stonehenge were built shifts once more. The answer may not require thousands of workers, but a single, brilliant key. The resonant power of sound may have carved the very stones that built our most enduring mysteries. Beyond the legends of levitation lies a tangible, physical principle with startling implications for how ancient quarries operated. Imagine the challenge of slicing through granite as if it were soft clay, leaving behind a smooth, almost polished surface without a single chisel mark. Modern experiments in acoustic engineering have shown this is not fantasy. When researchers apply a precise, resonant frequency to a block of stone, something remarkable happens. The sound wave travels through the material, concentrating energy along a predetermined line. This creates what can only be described as a sonic blade, an invisible force that causes the stone to fracture with a clean, almost surgical precision. The process is efficient and leaves behind a unique signature, a surface that flows smoothly without the rough, pitted texture of hammer stones or grinding. Now look at the evidence in the quarries themselves. Certain ancient sites show stone faces with undulating, fluid cuts that seem to defy the capabilities of Bronze Age tools. These are not jagged breaks from brute force, but graceful separations, as if the stone simply yielded along a line of intention. If the builders had mastered this acoustic technology, it would reframe quarrying from a feat of endurance into a symphony of applied physics. The monumental task of freeing a 100-ton block from the bedrock would no longer require years of pounding and pulverizing. A skilled operator, or a team of them, could theoretically guide a resonant frequency through the stone, encouraging it to crack perfectly along its natural crystalline planes. This knowledge would have been a closely guarded secret, a sacred science understanding that every material has its own voice, its own frequency that, when sung to it, could persuade it to open. The silence of the quarries today is deceptive. They may not hold the ghosts of countless laborers, but the echo of a forgotten technology that turned sound itself into the most precise cutting tool imaginable. A copper chisel, left in its natural state, would simply deform against granite's unyielding surface. Yet the evidence of ancient stonework suggests a different reality entirely, one where the metal itself was transformed. Legends persist, particularly in the high Andes, of a lost botanical formula. Stories tell of a specific plant, its juices extracted to create a liquid that, when painted onto the edge of a copper tool, granted it a temporary but phenomenal hardness. This was not a magic potion, but perhaps a sophisticated chemical process that altered the metal's crystalline structure on a superficial level, enabling it to slice through andesite for a brief, critical window before the effect faded. The secret was not in the copper alone, but in this ephemeral treatment, a recipe that has never been successfully recreated. This idea of temporary transformation finds a curious parallel in modern metallurgy. We know that through precise cycles of heating and rapid cooling, a process called quenching, the hardness of steel can be dramatically increased. What if the ancients had discovered an analogous but entirely different process for their own metals, a lost art of annealing or alloying that we simply do not understand? The proof may lie in the artifacts themselves. Occasional metallurgical analysis of unusual ancient objects reveals microstructures that defy explanation, metal grains arranged in patterns that should not be possible with the simple furnaces and techniques we attribute to those eras. These anomalies are the ghosts of a forgotten industrial science. They hint at smelting and tempering techniques that created super tools designed for a single, monumental purpose: to shape the very bones of the earth. The tools that built the megaliths may not have been crude implements of soft metal, but ephemeral masterpieces of material science, their true strength unlocked by a process that left no trace behind, except for the impossible cuts they made in stone. A straight line drawn on a map of Britain connects Stonehenge to the old Sarum settlement and then continues directly to the cathedral at Salisbury. This curious alignment is not unique. Across the world, from the plains of Peru to the temples of Japan, enthusiasts have charted countless such pathways, invisible threads they call ley lines, stitching ancient monuments together in a vast hidden web. The mainstream academic view is firm that these lines are a product of pattern-seeking human imagination, connecting dots that were never meant to be connected. Yet, the statistical coincidence of so many significant sites falling into such precise, long-distance alignments is difficult to entirely dismiss. If these alignments were deliberate, what possible purpose could they have served? One compelling theory points to geomancy, an ancient practice of harmonizing human structures with perceived energies of the earth. Proponents suggest that just as acupuncture uses needles on the body's meridian lines, megalithic structures were placed on the planet's own energetic pathways to stabilize or amplify a natural flow of power. Another, more tangible explanation involves astronomy and trade. These straight lines could represent ancient sight lines, not for energy, but for practical navigation. A prominent stone circle on a hilltop could serve as a waypoint for travelers, its position chosen so it lined up with the next distant monument, creating a kind of prehistoric highway system etched into the landscape itself. This idea of continental scale surveying is perhaps the most staggering implication. To intentionally place a monument so it aligns with another 150 miles away requires an astonishing grasp of geography and geometry. It implies the existence of a master surveyor's map of the entire region, a coordinated plan that transcended individual tribes and generations. This suggests a shared, sacred geography, a unified vision of the land that saw mountain peaks, river sources, and man-made monoliths as interconnected nodes in a single, living system. Whether these lines carried energy, information, or simply symbolic meaning, their potential existence points to a forgotten layer of planning. The true secret may not be in how they built, but in why they built here, and how each location was part of a grander design we are only just beginning to perceive. These silent stones speak in a language of spirals and symbols. Far from being blank monuments, many megaliths are canvases for intricate carvings, a complex code etched into their very surfaces. The Gavrinis tomb in France offers a stunning example. Its interior walls are almost completely covered in a breathtaking tapestry of swirling patterns, concentric circles, and graceful arcs. To stand inside that chamber is to be surrounded by a beautiful, impenetrable mystery, a message from the past whose specific meaning has been entirely lost. We are left with the profound sense that we are looking at a library, but one whose books we can no longer read. Interpreting these symbols is the ultimate historical puzzle. A single spiral might represent the journey of a soul, the cyclical nature of the seasons, or even a map of a specific celestial event, like the swirling path of a comet. The recurring zigzag lines found across different cultures could depict flowing water, a nearby river system vital for life, or perhaps something more abstract, like the perceived energy pathways of the Earth itself. These carvings were not mere decoration. They were a sophisticated system of recording and transmitting knowledge, a durable record meant to outlast papyrus, clay, and human memory. The stones themselves became the permanent repositories for everything the builders held sacred, from their deepest spiritual concepts to their most advanced astronomical observations. This transforms our understanding of these sites. They were not just temples or tombs, they were multidimensional archives. The alignment of the structure captured celestial movements, its location tapped into terrestrial energies, and its carved walls held the philosophical and scientific keys to understanding it all. The tragedy is that we have lost the cipher. We can measure the alignments and analyze the geology, but the stories, the prayers, and the instructions carved into the rock remain just out of reach. These stones are trying to tell us a complete story of a lost worldview, a unified vision of heaven and earth. Our challenge is to learn how to listen. A sudden and dramatic turning point in Earth's own story may hold the key to this ancient silence. The geological record from roughly 12,000 years ago reveals a planet in violent transition. A mysterious 1,000-year cold snap called the Younger Dryas abruptly reversed a long period of warming, with ice sheets advancing once more and ecosystems thrown into chaos. For the sophisticated culture we have been discussing, this would not have been a gradual change. It would have been a cataclysm. The leading explanation for this rapid cooling is the impact hypothesis, the idea that a comet or series of comet fragments struck the Earth's ice sheets, triggering a firestorm and a continent-spanning flood of meltwater. The ensuing climate shift would have been an extinction-level event for any complex society. This was not a single bad winter, but a planetary reset button. Think of the sheer logistics of that lost civilization. If they were a global, seafaring culture, as the theory suggests, their coastal cities and primary trade networks would have been the first to vanish beneath rising seas and tsunami waves. Their agricultural heartlands, dependent on stable climates, would have failed almost overnight. The survivors of such an event would have been scattered, isolated groups, their numbers decimated and their primary infrastructure utterly destroyed. In such a world, the highest knowledge becomes the most fragile. The intricate formulas for geopolymer concrete, the precise calibrations for sonic quarrying, the sacred mathematics of celestial alignment, these are not the first priorities for a community struggling simply to find food and shelter. Over just a few generations, the why behind the techniques would have faded, leaving only the how passed down as ritual. The master architect, once a revered scientist, becomes a shaman chanting old words whose original meaning is lost. The advanced technology devolves into a tradition, and the tradition eventually fades into myth. This is how you lose a science. It is not stolen or hidden, but fragmented and diluted by the sheer struggle to survive. The Great Flood stories found in over 500 cultures worldwide, from the Mesopotamian epic of Gilgamesh to the biblical account of Noah, begin to look less like fiction and more like a shared, traumatic memory of this very event. These are not tales of a simple rainstorm, but of a world-ending deluge, a divine punishment that washed away a previous age of humanity. The megalithic sites we study today, then, were not the beginning of something new. They were the enduring remnants of that previous age, the last great projects of a world in its twilight, or perhaps the first stumbling attempts of the survivors to rebuild using the shattered pieces of the old knowledge. The cataclysm hypothesis provides the most dramatic answer to our central question. It explains why such profound understanding could vanish so completely, leaving behind only the silent, magnificent stones and the ghost of a technology that history forgot. The challenge of the Baalbek stones is not merely one of weight, but of precision on a staggering scale. The trilithon, a foundation wall built from 3 stones each heavier than a fully loaded commercial airliner, was an achievement that would be difficult to replicate even with modern machinery. Yet the true heart of the mystery lies just a short distance away in the ancient quarry. There rests the Stone of the South, a colossal block of limestone estimated to weigh 1,650 tons. To put that into perspective, this single stone is heavier than a fleet of 350 family cars. It was cut and shaped with clean, deliberate edges, clearly intended for transport, but it was never moved. Its very existence in the quarry is a permanent question mark etched into the landscape. How do you even begin to transport something that heavy across a valley and then lift it precisely into place 20 feet high? The conventional explanation of log rollers and rope teams, which is already stretched to its breaking point with the 800-ton trilithon blocks, completely shatters when confronted with this monolith. The physics simply do not work. The ground would have turned to mush, the logs would have splintered, and the number of people required would have been an army of such immense size it feels more like legend than logistics. This forces a profound reconsideration of the entire site. The Romans, who built their magnificent temple of Jupiter upon this massive foundation, were inheritors, not the original architects of its deepest and most ancient layer. They built upon a pre-existing Cyclopean platform whose origins were already lost to time. The stone of the south is therefore more than a block of rock. It is a boundary stone of history, marking the absolute limit of what we believe was possible. It stands as the ultimate case study, demanding that we look beyond ramps and ropes for an answer. Perhaps the solution was not mechanical at all, but a form of applied physics we have yet to rediscover, the absolute peak of a forgotten science that could make even the most impossible stone obey. The scattered stones of Puma Punku do not look like ruins. They resemble the intricate, shattered components of a vast and forgotten machine, frozen in a moment of catastrophic disassembly. Each block of andesite and red sandstone is a geometric puzzle, carved with a level of precision that seems to defy its own ancient origins. The most famous of these are the H-blocks, massive stone forms with a series of perfectly spaced, perfectly parallel recesses and tabs. These are not simple notches. They are complex, interlocking features that would require a master draftsman with sophisticated measuring tools to design and machine-like accuracy to execute. The surfaces of these stones are not merely flat, they are flawlessly smooth, with sharp, crisp edges that meet at perfect right angles, showing no signs of the hammering or grinding we would expect from hand tools. Even more baffling are the precisely drilled holes, some that run straight through the hard stone, others that are blind holes of a consistent depth, each with a uniformity that suggests the use of a fixed, powered drill press, not a handheld tool spun between the palms. This is a level of manufacturing consistency we associate with modern machine shops, yet this site is attributed to the Tiwanaku culture, a people who, according to conventional history, lacked even the wheel or a system of writing. This creates a technological chasm that is almost impossible to bridge with our standard narratives. How could a society without pulleys or iron create such mathematically precise stonework? The disconnect is so profound that it forces a difficult question. Are we looking at the work of a culture we fundamentally misunderstand, or are we seeing the skeletal remains of a much older, technologically advanced civilization, whose most potent secret was not how to move the stones, but how to shape them with an ease we can scarcely comprehend? Puma Punku stands as a permanent challenge, a case study in impossible engineering that quietly dismantles our assumptions about the past. Perhaps the deepest mystery lies not in the stones themselves, but in our own unwavering obsession with them. We are drawn to these silent giants for reasons that transcend archaeology or history. They speak to a profound human need to believe that our species has previously achieved greatness, that we are not simply climbing an endless slope of progress, but are perhaps rediscovering a plateau we once inhabited. This belief offers a powerful antidote to modern anxieties, a hopeful whisper that if our ancestors could overcome their own monumental challenges, then we too possess that same dormant potential. The stones are a physical anchor for this hope, a permanent reminder that our story is far more complex and intriguing than any textbook summary. They force a necessary humility upon us. In an age of satellites and supercomputers, we still cannot fully explain how a 1,650-ton block was moved, or how a stone box was carved with a precision we would struggle to replicate. This gap in our understanding is not a failure but a gift. It reintroduces a vital sense of wonder into our world, a feeling that there are still grand puzzles waiting to be solved. This enduring sense of mystery is the engine that drives both the dedicated researcher and the curious visitor. It is why we continue to fund expeditions, develop new scanning technologies, and stand in the shadow of these structures, feeling a connection that is difficult to put into words. We are not just seeking their secrets, we are seeking a reflection of our own lost capabilities, a glimpse of a different path our collective story might have taken. Our quest to understand the megalith builders is, in the end, a quest to understand the depth and resilience of the human spirit itself. It assures us that even the most formidable obstacles can be overcome, and that the greatest chapters of our history may still be waiting patiently to be read. The scattered pieces of this ancient puzzle suddenly click into a breathtaking new image. The acoustic science that could cut stone, the lost chemistry for casting geopolymer blocks, the advanced metallurgy for temporary super tools, and the celestial mathematics encoded into architecture were not separate, isolated discoveries. They were different facets of a single, unified system of knowledge, a holistic technology that viewed the world as a living, interconnected whole. This was a science that did not seek to dominate nature with brute force, but to harmonize with it, to understand and utilize the subtle energies, resonant frequencies, and hidden properties of the materials at hand. It was a technology of integration where the practical act of building a wall was inseparable from the spiritual act of aligning it with the cosmos. The master builders were not just engineers or priests, they were both, their work a sacred dialogue with the universe itself. This revised perspective does not erase the glory of the Egyptians or the Incas. Instead, it reframes them as the brilliant inheritors of a much older, grander tradition. They were the custodians of a legacy, the last generations to understand and apply principles that had been developed over millennia, perhaps by a precursor civilization whose name is now lost to us. These later cultures built upon the foundations of this forgotten world, adapting its core principles to their own unique expressions and needs. When we look at the Great Pyramid or the walls of Sacsayhuaman, we are not seeing the beginning of human ingenuity. We are witnessing its magnificent twilight peak. This realization opens up a past that is far richer, more complex, and infinitely more mysterious than our standard timelines suggest. We are left with a profound sense of a lost chapter in the human story, one where our ancestors achieved a symbiotic relationship with the planet, creating a legacy in stone that continues to whisper its secrets across the ages. These silent, colossal stones scattered across our world are far more than monuments to forgotten kings or gods. They are enduring questions carved in rock, each one a permanent challenge to our understanding of human potential. The secrets of the megalith builders and the tools history forgot remind us that our past is a vast and intricate puzzle, still missing crucial pieces. This realization is not an end but a beginning, an invitation to look at the ancient world with fresh eyes and a more open mind. Let this exploration be a starting point for your own curiosity. Research further, visit these sites if you ever have the opportunity, and always feel empowered to question the established narrative. The greatest secret these stones may hold is not about them, but about us, the idea that the very capacity for such wonder and profound achievement still resides within humanity, waiting to be rediscovered and reawakened in our own time. If you found this journey into the forgotten past as fascinating as I did, please like this video and subscribe for more deep dives into history's greatest mysteries. I would love to hear your own thoughts and theories in the comments below.